Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the Fajan Rule. Before starting the Fajan Rule, I would like to know you that in reality, in chemical bonding, the 100% covalent bond is possible, but 100% ionic bond is not possible. That means in case of ionic bond there must be some covalent character also, and that covalent character is measured by a rule called Fajan rule. So let us start this topic by the Fajan rule, and I'm writing that. First of all, I'm writing in reality 100% covalent bond is possible. Covalent bond is possible, which we are going to discuss in the next lectures from the covalent bonding. So what next? But 100% ionic bond is not possible. 100% ionic bond is not possible. That means there must be some covalent character in ionic bond. So the study of covalent character in case of ionic bond is done by the person called Fajan, and the rule given by him is called the Fajan rule. So as an example, I'm going to write, we know that the ionic bond is always formed between cation and the anion. What is cation? Ion that bears positive charge. And what is anion? The ion that bears negative charge. So what's gonna happen? We are having cation, that's a positive charge, and let me mark, this is the some sort of electronic cloud. It's an electronic cloud around the cation. Now let's talk about the anion. That's my anion. We are having excess electron in case of anion, so the electronic cloud of anion will be much greater than that of the cation. Now, to understand this topic, let me first of all delete the electronic cloud of the cation. So what is cation? It's an electron deficient species which is going to attract the electronic cloud of the anion to get electrically neutral. So what's gonna happen, that cation is going to distort or attract the electronic cloud of anion towards itself, which is going to be like this. The cation has attracted the electronic cloud of anion to get electrically neutral, due to which what's going to happen, initially cation was having one positive charge and anion was having one negative charge. Due to the distortion of electronic cloud of anion by the cation will acquire a delta positive charge and anion will acquire a delta negative charge, though the value of delta which is less than 1, because it's the case of neutralization of cation by the electronic cloud of anion. So anion also get neutralized, due to which they will acquire a delta positive and delta negative charge whose magnitude will be less than 1. So this whole process This whole process of distortion of electronic cloud of anion by cation is called polarization. Is called polarization. From here I'm mentioning what has happened here. The distortion of distortion of electronic cloud of anion by cation has taken place, due to which they get electrically neutral, not completely, so due to which they will acquire a delta positive and delta negative charge, and here the magnitude of delta will be less than 1, which signifies the neutralization of cation and the anion. So this whole process is called polarization. So let me define what is polarization. What is polarization? It is the process in which distortion of electronic cloud of anion by cation takes place. Due to which the neutralization of cation as well as anion begins. It begins but does not get neutralized completely. The neutralization of cation as well as anion begins, comma, which give rise to covalent character, in ionic bond. So now that's all about Fajan rule, and that's the topic called polarization, which is the base for the neutralization of cation and anion, forming the cation with a delta positive charge and anion with a delta negative charge whose magnitude is less than 1, which give rise to the covalent character in case of the ionic bond. So now let's talk about cation and anion separately. I'm mentioning that's my cation, and here I'm mentioning that's my anion. In case of cation, we will talk about the polarizing power of cation, and for anion we will talk about the polarizability of the anion. So polarizing power, let's talk about the first of all cation and the polarizing power of the cation. The polarizing power of the cation is directly proportional to the charge density. We have talked about charge density in the previous lectures. The charge density is represented by a symbol phi. I'm writing that polarizing power is directly proportional to the charge density, that is phi. Now, what is charge density? The charge density is equal to the charge divided by the radius. Now let's talk about the polarizing power of the cation in a specific group of the periodic table. Let me take the group number 1. That's lithium, sodium, potassium, rubidium, cesium and the francium. Now group number 1 of periodic table usually acquires the oxidation state of +1. So I'm mentioning the +1 charge on each and every element. Now, as we all know, when we move down the group, when we move down the group, comma, radius of ion will increase, due to which what's gonna happen, the charge density will decrease down the group, and hence what's gonna happen, the polarizing power of the cation will decrease down the group, will decrease down the group. That means as you move down the group, the polarizing power of the cation will decrease, and hence polarization will takes place to a very minimum extent, and hence the ionic character will be much greater than the covalent character in a specific ionic bond. So that means in case of group number 1, the lithium, the Li positive, will have the maximum polarizing power, and the compounds found by the lithium will be more covalent rather than ionic. Now let's talk about the polarizability. Now I'm mentioning about the polarizability. In case of anion, we will talk about the polarizability, we will talk about the electronic cloud. The bigger the electronic cloud, which is not under the control of the effective nuclear charge, will get easily polarized. So I'm mentioning in case of polarizability, in case of anion, I'm writing the bigger the electronic cloud, the bigger the electronic cloud of the anion, which is not under the control, which is not under the control of the effective nuclear charge, control of the effective nuclear charge. That type of anion will get easily polarized by the cation. So that means in case of anion, we were talking about the to how much extent the electronic cloud of that anion will get polarized by the cation, and this process is called polarizability for the anion. So that means in case of anion, the situation is vice versa. That means that polarizability of the anion, that means its efficiency to get polarized by cation, is inversely proportional to the charge density of that anion. So lesser the charge density, more scattered will be the electronic cloud, which will get easily polarized by the cations. So hence the polarizability of the anion will increase. So let me talk about any anion group. Let's take an example of group number 17. Now I'm talking about the group number 17. That's fluorine, chlorine, bromine, iodine. That's group number 17. I know that the group number 17 always acquires a unit negative charge, the F negative, Cl negative, Br negative, and the I negative. Now, as we move down the group, what's gonna happen? As we move down the group, comma. Firstly, the effective nuclear charge will decrease. The effective nuclear charge will decrease. What's next? Radius also increase down the group, due to which what's gonna happen, the charge density will decrease down the group. Charge density will decrease down the group. What I have just said, as the charge density will decrease, the polarizability will increase. So hence I'm mentioning polarizability. Polarizability will increase down the group. That means in case of I negative, the electronic cloud is very much scattered. I'm mentioning it's having the first of all, it is having the very maximum polarizability. So the electronic cloud is more scattered, which is easily polarized by cation. Having higher polarizing power. So the ionic bond formed by ion negative will be more of covalent character rather than the ionic character. So that means if we talk about the compound as called lithium iodide, will have the maximum covalent character instead of ionic character. Maximum covalent character, because Li positive has maximum polarizing power and I negative has maximum polarizability. The Li positive has maximum power to attract or distort the electronic cloud of the I negative, and on the another hand, in case of I negative, the electronic cloud is not under the control of effective nuclear charge. The electronic cloud is more scattered, which is easily polarized by the lithium. So that means the compound lithium iodide will have the maximum of covalent character rather than the ionic character. So let me take an question. Let me take an question as an example. I'm mentioning we are having lithium chloride and the potassium chloride. So the question is, out of these two compounds, which will have the more covalent character? In the lithium chloride and potassium chloride, the chloride is common, so let's forget about it. Now let's talk about the lithium and the potassium. The cation is Li positive and the K positive. In case of Li positive, the radius is less than the radius of potassium. So in case of potassium, the radius is more. That means the charge density of Li positive is greater than the charge density of potassium positive, because charge density is inversely proportional to radius. So that means the polarizing power of lithium will be higher than that of potassium. So I'm mentioning the lithium will have more polarizing power than that of the potassium. Hence lithium chloride will be more covalent than potassium chloride. So this was the first example. Now let's take another example. The example is NaCl and the NaBr. Out of NaCl and the NaBr, which will have the more covalent character? Now here the sodium is common in both, so let's forget about it. Now let's talk about the chloride and the bromide ion. The chloride ion and the bromide ion. So the radius of chloride ion is less and the radius of bromide ion is more. That means the charge density of chloride ion will be greater than that of the charge density of bromide ion. Now, as we all know, for the anion, we have to talk about the polarizability. So, lesser the charge density, more is the polarizability in case of anion. We are talking about anion in case of NaCl and the Br, the Cl negative and the Br negative, these are the anions. So, the polarizability of bromide ion will be more. Hence, the electronic cloud of Br negative will be easily distorted by the sodium, and hence the covalent character of NaBr will be greater than that of the NaCl. So I'm writing NaBr will have more covalent character than NaCl. So that's it. I hope you got today's lecture. So in case of cation, we have to talk about the polarizing power, the power by which it will attract the electronic cloud of the anion, and for anion we have to talk about the polarizability, how much the anion can distort the electronic cloud by the attractive pull of the cation. That's called polarizability. So polarizing power is directly proportional to charge density and polarizability is inversely proportional to charge density. So as we move down the group, in case of cations or in case of metals, down the group polarizing power will increase, and for the anion, for the non-metals, as you move down the group, the polarizability will increase. So that means that the first member of any group will have the maximum polarizing power, and the last member of any group in case of non-metal will have the maximum polarizability. So the compound formed will be more covalent than that of the ionic. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.